The topic that we are going to discuss is models of distributed system. Here we are going to study now what are the different models in a distributed system. The first one is architectural model. What is an architectural model? An architectural model of a distributed system is concerned with the placement of its parts and the relationships between them, such as client-server model, peer-to-peer model. The client-server model can be modified by the partition of data or replication of cooperating servers, the caching of data by the proxy servers or clients, use of mobile codes, mobile agents, the requirement to add, remove mobile devices in a convenient manner. So basically the architectural model depicts the various components of a system and the dependency between them. Next comes the fundamental model. The fundamental models are concerned with a more formal description of the properties that are common in all the architectural models. There is no global time in a distributed system, so the clocks on different computers do not necessarily give the same time as one another. All communication between processes is achieved by means of messages. Message communication over a computer network can be affected by delays, can suffer from a variety of failures, and is vulnerable to security attacks. These issues are addressed by the three models collectively known as fundamental model. So fundamental model is going to address all these three issues. The issue of synchronization is addressed in the interaction model. It deals with the performance and with the difficulty of setting time limits in a distributed system. Then comes the failure model, which attempts to give a precise specification of the faults that can be exhibited by processes and communication channels. Next is the security model, which discusses the possibilities, threats to processes and communication channels. Now we will study architectural model in detail. The architecture of a system is its structure in terms of separately specified components. The overall goal is to ensure that the structure will meet present and future demands on it. Major concerns are to make the system reliable, manageable, and cost effective. An architectural model of a distributed system first simplifies and abstracts the functions of the individual components of a distributed system, and then it considers the placement of the components across a network of computers, the interrelationship between the components, that is their functional roles and the pattern of communication between them. So first of all, it identifies the various components in a system, then the interrelationships or the connectivity between them, how they are connected, what should be the flow of information, etc. The initial simplification is achieved by classifying the processes as server or as client or as peer. The classification of process identifies the responsibilities of each and hence help us to assess their workload and to determine the impact of failures. So by specifying or by identifying their roles, we will be able to identify their workload and what will be the impact of the failures in each of them if they fails. The result of this analysis can be used to specify the placement of the processes in a manner that meets performance and reliability goals of the resulting system. From this diagram we can see that there are various clients and servers, and they are invoking a request message and getting the response as a result. Fundamental model. Models based on the fundamental properties that allows us to be more specific about their characteristics and failures and security risks that might exhibit. The purpose of this model is to make explicit all the relevant assumptions about the system we are modeling, to make generalization concerning what is possible or impossible given those assumptions. The aspects of distributed system that we wish to capture in our fundamental model are intended to help us to discuss and reason about. There are various types of fundamental models. First one is interaction model. Computation occurs within processes. The processes interact by passing messages, resulting in communication and coordination between processes. The failure model corrects the operation of a distributed system and is threatened whenever a fault occurs in any of the computers on which it runs or in the network that connects them. Our model defines and classifies the faults. This provides the basis for the analysis of their potential aspects and for the design of systems that are able to tolerate faults of each type while continuing to run correctly. So interaction model we have seen is basically concerned with the coordination of messages, the synchronization of activities. That means it is concerned with the time stamping of the various events. Failure model, it is concerned with the faults that are occurring in the process of communication and how those faults are handled, are masked, that is shown in the failure models. Then security model, it prevents the communication between the processes from the attacks either by the external agent or by the internal agent, and it maintains security by using cryptographic algorithms, by using secure channel and many other mechanisms. Interaction model in detail. Distributed systems are composed of many processes interacting in complex ways. Multiple server processes may cooperate with one another to provide a service. A set of peer processes may cooperate with one another to achieve a common goal. There are two types of interaction model, synchronous and asynchronous. In distributed system, it is hard to set time limits on the time taken for a process execution, message delivery or clock drift. Two opposing extreme positions provide a pair of simple models. First has a strong assumption of time and second has no assumption of time. Synchronous distributed system define the following bounds. The time to execute each step of a process has known lower and upper bounds. Each message transmitted over a channel is received within a known bounded time. Each process has a local clock whose drift rate from real time has a known bound. That means there is a defined time or a time limit to execute a particular task, the lower limit as well as the upper limit. That means how much delay is possible in starting or executing a process and how much extra time it can take till completion. Then each message transmitted over channel is received within a bounded time. There is also a time limit for receiving a message. If a message is not received within that bounded time, it will be discarded. Each process has a local clock drift rate. So the local clock has a bound on its drift rate. Okay, drift rate is the deviation from the time. Real time is a drift rate. So if it is it should not go beyond that particular drift rate. Asynchronous distributed system. Many distributed systems, for example the internet, are useful without being able to qualify as synchronous system. Therefore we need this model. In asynchronous model also there are certain properties. There is no bounds on process execution speed, message transmission delays, and clock drift rate. So it is just the opposite of the synchronous model. In asynchronous model we do not have any types of bound on the execution speed of the process, or on the message transmissions delays, or on the clock drift rates. Failure models. In a distributed system, both process and communication channel may fail. That is, they may depart from what is known as the desirable behavior. So this is the definition of failure, that is departing from the desirable behavior. The failure model defines the ways in which failure may occur in order to provide an understanding of the effects of failure. So failure model is concerned with what are the various types of failure that may occur in a distributed system and what is the effect of them if they occurs. Omission failure, the first type of failure, it refers to cases when a process or communication channel fails to perform the actions that it is supposed to do. Arbitrary failure describe the worst possible failure semantics in which any type of error may occur. A process may return a wrong value in response to an invocation, or anything may happen which we have not known from beforehand. So these are the instantaneous failures and we have to, for which we are not prepared with. Communication channels can suffer from arbitrary failures. For example, message contents may be corrupted, or non-existent messages can be delivered, or real messages may be delivered more than once. So, but arbitrary failures in communication channels are very rare because communication software is able to recognize them and reject the faulty messages. As we have seen through examples such as checksum. Checksum detects the corrupted messages, and message sequence numbers can be used to detect non-existent and duplicated messages. Timing failures. Timing failures are applicable in synchronous distributed system where time limits are set on process execution time, message delivery time, clock drift rate, etc. Security model. The security of a distributed system can be achieved by securing the process and the channels used for interaction and by protecting the objects that they encapsulate against unauthorized access. The security model identifies the process, possible threats to processes, and communication channels in an open distributed system. Some of these threats relate to integrity. Malicious users may tamper the messages or may replay them. Other threaten their privacy. Another security issue is the authentication of the principal on whose behalf a message was sent. Secure channels use cryptographic techniques to ensure the integrity and privacy of the messages and to authenticate pairs of communicating principals. So in security model, it is concerned with the securing the processes and the channels. It is used to encapsulate the messages that is going to be transmitted in communication by using various cryptographic algorithms. It is used to secure the channel by using various mechanisms such as secure circuit layer programming, etc. All these techniques we have studied in detail in the subject information security system. So that is all with the system models in distributed system.